Hi, everyone. Hugo Bowne-Anderson here. I work in data science and evangelism and developer relations and all these types of fun things. And I'm excited to get spooky on Halloween today with you, talking about Dask for everyone. And a lot of the things a lot of people are thinking about these days, but in particular, a story from a company called Coiled, which is incredibly close to my heart. But this is a general pattern we're seeing in the space at the moment as well. And I want to make that clear. So the TLDR, if you want to leave after a minute or two, is that Dask makes distributed computing, particularly with the PyData stack, but distributed computing more generally easy. Then when you want to do stuff at scale or productionize stuff, IT adds lots of additional challenges. What happens then? A lot of people are building interesting products, such as Coiled, to try to make this easy again. So on Dask, making distributed compute easy, I'm going to skip this. I'll say a few words, but there are many talks at this conference about Dask. So definitely check all of them out. We're going to focus on the additional challenges with a specific example. And the types of products in Coiled that we're talking about, the punchline is you can pip install Coiled. It comes as a pip installable package. You can import Coiled and then get your cluster spun up on AWS, GCP, Azure, or on-prem in a matter of minutes. You'll be hard pressed to make a cup of coffee in the time unless maybe you've got an AeroPress on your desk. So what I'd like to do is start with an example of scaling pandas and machine learning workflow. Okay, so you've got some tabular data in a pandas data frame. You're using XGBoost because, I don't know, you love Kaggle competitions. No, that's all jokes aside, because XGBoost is cool and fast. Okay, so this slide is incredible. Okay, I don't actually mean, we made a beautiful slide for you all to watch. What I mean by that is the fact that in 5 lines of code, you can get a model up and running and training on a data set. So let's just have a look at what's happened here. We've Conda installed XGBoost and Pandas. Then we've wgetted a data set. So it's the Higgs boson data set, and it's a small version of it because we're going to work on it initially locally with Pandas and XGBoost. Then we import our libraries. Then we read in the data frame, the CSV into a data frame, and then we train our model on the data frame. Okay. Now, in the past 10 years, of course, we've seen a lot of incredible APIs developed in the PyData ecosystem. And this speaks a huge amount to the rapid adoption and the hockey stick growth we've seen in the Python space in particular. Okay, so this is how you would do Pandas and XGBoost on a laptop, right? But most laptops have several cores these days. So if you want to do some parallelization or in your hyperparameter sweep or something along those lines, I'm sorry, I just wanted to make clear, I did say this in passing, but what I've just done and showed you works really well and is fully accessible to anyone with a laptop and some time to learn. You need to check out some API docs, get some software installed, and then you're up and running, okay? So as I was saying, if you want to, leverage all the cores on your laptop, you can think about doing that in a relatively straightforward way, which we'll see now using Dask. Okay, so this is Pandas and XGBoost, and using some form of distributed compute on your local machine in order to speed things up. Okay, so we conda install all our things again. Actually, this looks really similar to the code before, and I'll point out the only differences. We're importing Dask data frame as DD instead of Pandas as PD, and we've changed pd.readcsv to dd.readcsv. This is beautiful. One of the many reasons I love Dask is that not only does it mimic the Pandas API or the NumPy API or the scikit-learn API, depending on what you're trying to do and what you want to be doing, but under the hood, for the most part, it runs the code you think it's running. And what that means is that your mental model of what's happening in the backend is actually what's happening. So, for example, you don't battle with JavaScript errors Java errors when importing a data set. So what I've just showed you will work well and fully accessible today with anyone with a laptop and a bit of time to learn and maybe a bit more time to learn. You need to install Dask and get a few things up and running there. But, if you have a bit more time to learn, you can do all of that, okay? So what if you want to be leveraging a cluster using distributed computation that's not on your laptop, okay? So then you'll be using, as we've just seen, Pandas and XGBoost and Dask, but not on a laptop, on a cluster. So let's say, for example, I don't know, you're at work and you find out you have a Kubernetes cluster that you can access, okay? So what do you do then? Hopefully it would be somewhat straightforward as the previous example. So we could try kind of installing this stuff, then importing our packages, namespaces, and then bring in our data. Notice that this is the large data set now, okay? The large Higgs boson data set. So we're going to really try to leverage the distributed compute of our Kubernetes cluster there. And then we train the model. So fingers crossed, whoa. Fingers crossed it works. And as we'll see, there are lots of many moving parts that go into this. And so this is what the next part of the story is going to be about, how we get that code up and running. And the truth is, this works well, as I write here, and it is fully accessible today to anyone with a whole variety of different skills and pieces of knowledge that we're going to try to put together, okay? So how do we set this up? So I'm going to tell you something we've seen in terms of kind of the general patterns that we see, people trying to figure this out, how to get the cluster up and running, or Dask and XGBoost and Pandas, for example, up and running on a cluster. So you may Google Dask on the cloud, and there you go. The Dask docs are pretty good, okay? So we see there's a page on cloud deployments, and I see there's a managed Kubernetes service. There are a few other things. So let's say I'm going to go and create an AWS account, and I need to, do some things, and maybe if it's my work stuff, I need to get like some secrets, a key and a token or something along those lines. And then I'm in there and it's like, oh, how many clusters do I want? How many node pools, that type of stuff. So trying to get my Kubernetes cluster, trying to get a piece with that. And then, all right, no, I've got Linux locally, so I've got to install kubectl. Okay, so I do that. That sounds good. So now we're back here, and hopefully, with all this stuff, and I probably need to put a bit more information in here in order to access the cluster. And fingers crossed, I can execute this code now after doing that setup. And I have a module not found error, and that's no module named XGBoost. So I've installed XGBoost, I've imported it, and the import error is from the remote workers on the cluster, right? So on this cluster that I'm trying to leverage, I have XGBoost locally, but I don't have it out there. So what I need to do now is make sure that my environment, my computational environment, matches locally and up on the cluster. So how do I get all my environment, all the stuff I want up on all my workers on my Kubernetes cluster? Okay, so I do a bit of research and I realize that there's something called Dask Docker, which can allow me to get containers all up and running on all my workers. And I do a bit of command line stuff and figure this out. That's kind of straightforward, but okay. So having done that, then I'm like, okay, now I've got everything up and running there and down here. That should be chill. Okay, what's happened there? I've got an S3 permission error. I cannot read this. Yeah, so the problem there is that my AWS credentials are not on the remote workers. So when they try to access the data set, they can't. So I need to give them permission somehow now as well. So what I'm going to do is upload my AWS credentials so that every worker can see them. Do not do this, and we'll see why later. But what I just did is I put secure information across potentially non-secure networks. Okay, so this type of stuff is now available to potentially a lot of people who I don't want to have access to these things, and who IT in particular may be relatively, if not more so, unhappy with. Okay, but I've done it, and look, it actually works. So essentially, what I've done is I've gone from Pandas and XGBoost locally to doing it quickly, leveraging the distributed compute of my laptop to use Pandas plus XGBoost plus Dask locally. And then to leverage the power of the cloud, I've done it on a Kubernetes cluster, and it's working. Now, we encountered some issues, stuff that will come up again. But having said that, it actually works, which I'm pretty excited by. And look, I can see all my cool task stream and all the processing happening and that type of stuff. Maybe I've got some split apply combines going on here or something along those lines. So that's really cool. I got it up and running there. So this does feel really good. And now we do have tools to scale. I'll say anything. It's really nearly anything, to be honest. And what I mean by that is, if you go and check out dask.org and have a look at all the different interoperable packages and frameworks. So you can distribute scikit-learn, XGBoost, Pandas, NumPy, Rapids for all of your GPU desires, Xarray, Pangeo, all of these things. If you have scalability challenges and you're using a variety of PyData and other types of packages, I very much encourage you to check it out. Okay, and then we see some. That's like mitosis, perhaps. There was a mitotic spindle and maybe some motor proteins there. Cool thing is you can even try GPUs for a while. That's also difficult for other reasons. I'd direct you to check out Matt Rocklin, who he was the creator of Dask, along with several other people, but he made the first commit and CEO of Coiled, among many other things. But check out his talk from NVIDIA's GTC about deploying with GPUs. This is nice though, okay? Things are good until IT finds out. And this will lead to a series of pretty embarrassing questions that many of us may have been involved in previously. So firstly, they come to me and they say, you're spending 17K a month. The work you're doing is fine. I appreciate that because I'm always striving for fine work. But they've told me I've left up 2 idle clusters that have been on for a long time. And each of the early, so yeah, there were load balancers that remained active, and that's totally on me. And this happens, right? They've also told me that there's an open, insecure network connection, okay? So not only can anyone connect to my schedulers and run arbitrary Python code, but I'm actually sending sensitive company data on unencrypted connections, okay? That's also on me. And when I did it, I actually told you never do what I'm doing, okay? And these are the lines of code that actually did it. And look, with great power comes great responsibility, right? Because the power to be able to write 2 lines of code to do this type of stuff can create a lot of harm as well. So let's be mindful of that. Right? And on top of that, those AWS credentials allow impersonation. My teammates are operating as me, and anyone can connect in and pretty much do anything. But nothing bad happened. Having said that, we need to be more careful, okay? So this is good though. I've demonstrated proof of principle, got out some early results. Perhaps some business leaders were like, hey, this is good stuff. Can we do more of this? All the teammates, people in the organization want to use the same system. That's really cool. I've set it all up. So now I'm kind of in charge, which is woohoo, a career change. Having said that, I just wanted to train an XGBoost model, and I'm a data scientist, and now I'm kind of been shoehorned by myself into an infrastructure position, which not only involves all these headaches of setup I just showed you, but a large amount of non-trivial maintenance as well. Okay, so what I want to do is go back in time and try a different approach. Okay, so we're going to rewind. We're going back through our Dask setup journey. Okay, and what I'm going to do instead is I'm going to introduce you to something called Coiled. Okay, which is a company and product that Dask maintainers have developed, among other people. But the pattern I just showed you essentially was one of the raison d'etres for Coiled. Okay, so Dask maintainers saw this pattern, the pain, the suffering, the headaches, the harm happen time and time again. And some of them made a company to automate it. And that company is Coiled. And as I said, this is a general pattern as well. Maybe I'll say a couple more words about this. what I mean by that is, not only is this, I mean, this doesn't only pertain to Pandas and XGBoost, right? But not only is it a general pattern for Dask, but this is a general pattern for compute in general, whether it's trying to distribute compute, whether it's trying to do scalable compute, whether it's trying to deploy things in production, deploy models in production, for example. We don't have good systems yet. We're trying to build them. This industry, tool builders are trying to build them to connect local experimentation with at-scale deployment and large-scale training and scalable distributed compute, right? So moving from notebooks to the cloud, right? And it comes in all varieties of shapes and packages. And I'll just point out, if you notice kind of what is now a really mature PyData stack, nearly every package in the PyData stack is about initially leveraging local compute in order to do science. It isn't necessarily about doing large-scale deployable compute in production. Dask is probably one of the packages in the PyData stack which is on the journey there, but it's a story that we're seeing time and time again now, that data scientists need to figure out how to do distributed compute and deploy their models, among other things. Okay, so this is kind of, you know, the next level of the industry, so to speak. So how does Coiled work? And in all honesty, it is nearly as straightforward as this. You pip install Coiled, then you import it as you would anything else, and then you create your cluster. And this will take a minute or two. So to kind of reiterate the type of problems that we need solved and that Coiled's working towards, we need hosted Dask clusters. Okay, so a question we hear a lot is, how do I launch many Dask workers and connect them together? So what Coiled does in the background uses low-level cloud APIs to provision resources as you need them. Takes a minute or two, and it's available on the 3 clouds and on-prem as well, okay? Huge challenge that we saw of managed software. How do I get all the libraries I need installed on my workers? And the approach Coiled takes is they solve in environments on their servers, excuse the typo there, build images and push them to container registries. And they can also store solved environments for local use by you or others. And there's a Coiled create software environment function, which allows you to specify anything from content channels, pip, or whatever it is. Now, in terms of thinking about the type of ergonomic tools data scientists need and love in order to, I suppose, do their work at high velocity and stay in flow states, we really need to think more about how such frameworks can interoperate with flexible development environments. Okay, so let's say I use VS Code or PyCharm or Jupyter Notebooks, Jupyter Lab. How do I access my clusters through that? And what Coiled has done is they've developed a system where they can proxy connections from anywhere. So they don't force you into their development environment. And like Dask, Coiled is designed for integrating into wherever you like to work best, okay? Another problem is that of cost management. So how do I keep costs down? Coiled will track usage per users, per team, shut down idle clusters by default, and scan for idle resources. And I think one thing we're thinking about the individual data scientists here, but we're actually thinking about how they're embedded in an organization as well. So who are the key stakeholders here? There are the data scientists and analysts, of course, but then there's IT, which we've spoken to. Then there are team leads who are very concerned, of course, necessarily so, about cost management. They'll also be concerned about telemetry, which we'll get to in a second. But there's also the challenge for data scientists of executing code as quickly as possible, and of course leveraging the capabilities of GPUs is important for that. So a common question that we hear a lot is, how do I leverage advanced hardware and libraries like Rapids, PyTorch, XGBoost, Blazing SQL, and so on. And to that end, Coiled will provision GPUs for you and includes pre-configured software environments that you can use and modify. There's a challenge of security, which we've already talked about, with respect to data, sensitive data, and how we can make sure that no one else sees it. So, I mean, table stakes here is to have end-to-end network security and to manage resources. You can manage it all inside your cloud account. This works on-prem as well. So, as we've said, it's multi-cloud and on-prem, which is super exciting if your data isn't on Amazon, for example. And I thought just in the end to wrap up by talking about how it scales in human dimensions. And this is what we're seeing a lot of now. We're seeing, what do I want to say here? I want to say that the open source stacks have been very good at meeting the needs of individual data scientists, analysts, and researchers. But when we embed people in organizations, there are all types of other needs that arise that we've already seen throughout this talk, okay? But we still want to meet the needs of humans working with data through computational engines, right? So we want to make the software and stack and products as human-centric as possible. And this is why, for example, Coiled makes sure that you can drive from anywhere and use your own development environment. That's why they've made sure there are pre-configured software environments. On top of that, it's one of the reasons to make sure that there's a freemium model with credits that renew every month, okay? So to wrap up, it scales to human needs and also to organizational needs. You can deploy into your own infrastructure. You can manage users, teams, quotas, track usage, gather telemetry, and there's end-to-end security and best practices. So I'd just like to wrap up by thanking PyData Global for having me talk here and thanking you all for joining. I've got no idea what time zone you're in. I'm in Sydney, Australia, and it's 7 p.m. on a Friday. But I really appreciate you all sticking around and listening, and I wish you a very spooky Halloween. So maybe we've got a few minutes for questions. Great. So we have a fantastic question from Andreas Known. I hope I pronounced your name correctly. If not, my sincerest apologies. You are new to distributed computing. Welcome to the world, the wonderful, scalable world of distributed compute. You've got a great question, Andreas. How does Dask compare to Spark in terms of scope, performance, and ease of setup? So First, I just want to acknowledge that I'm incredibly biased here. I've been working in Python for over a decade. For the most part, I love writing Python code, and I love the PyData stack, okay? If you joined a team that was already using Spark, and they were very happy with that, I'd encourage you to do so. If you're starting in distributed compute and want to figure it out and already use Pythonic tools, such as NumPy, Pandas, or scikit-learn, I think Dask compares wonderfully there. And in particular, you'll note that, as I stated, Dask is embedded in the PyData ecosystem in such a way that the people who wrote Dask code were writing Pandas code and writing scikit-learn code and writing Dask code. So when you're operating in that space, I think it's far more straightforward to get up and running as quickly as possible there. And in terms of performance, it's incredibly performant in comparison with Spark. I mean, you'll see benchmarks go each which way, but there isn't a huge difference there for a lot of types of jobs. And ease of setup, if you're already comfortable with the PyData stack, it's relatively easy to set up as well. So I hope that's helpful. Fabian has a great question. Fabian enjoys the free monthly credits of Coiled. I'm so glad you played around with Coiled and you enjoy it, which helps you play around and testing the setup. Will Coiled keep this free credits for the foreseeable future? Thank you for your phrasing that question like that. My understanding is that they will keep the free credits for the foreseeable future. I'm not sure how foreseeable that is, but I definitely haven't caught wind of any plans to not do that. And I know several people at Coiled who love that they give free credits. So thank you for your great question, Fabian.
Okay, so I just wanted to ask. So you just demonstrated a method by which we could deploy, and then you showed how it isn't right to upload your credentials, right, in the previous approach. So my question is, the new approach you just showed, does it solve that problem?
Yeah, exactly. So Coiled is very much making sure that all of your information remains secure when needed.
Yeah, great.
Yeah.
This was a really great talk, and I personally enjoyed it. And it's actually, this talk is actually for people who love experimenting. And thank you for being here. And we love this talk.